Hello everybody, this is Mr. Joseph. I'm just going to help you do this homework real quick. So it says 6.7, but it's really 6.2. So what we're going to do is we're going to draw vector A, and we're just going to assume that it's flat. And then draw vector B. And they make an angle of 120 degrees. So in order to use a parallelogram rule, pretty much what you're doing is you're taking one of the vectors, which is like say A, and you're moving it to the tail of the other vector. And the way that I like to think about this is pretty much now it's like if you go from B to A, the resultant vector ends up at the tip of A. Or what you can do is you can take B and put it here and do the opposite. So I'll just use the color, let me use the highlighter, just use green. You go from A to B, and you see how you still land in the same spot. So that's how you can tell like where the resultant vector can be. And if that's 120, that means this is 120, and that makes this 60, and that makes this 60. So if we kind of zoom out and just look at the triangle, you got 60, 8, 6, and you want to know your resultant vector, which is right there. So we're going to use the law of cosines. And this is the formula. And then I'm just going to take the square root and start filling out all the numbers. And you get 7.21. All right. So now what you want to figure out is you want to take your bottom vector, which is this one right here, and it's flat, so you can pretend like it's an x-axis, and you want to see how many degrees will it take to get to the resultant vector. So this ends up being theta. So this is when we use the law of sines. So you get sine of 60 over 7.21 equals sine of theta over 6. You cross multiply. Let me just move this. Okay. Divide by 7.21. And then take the inverse. And theta equals 46.10 degrees. Okay? That's pretty much how you do this first one. I know this one's a little weird because it's 120 degrees, so sometimes it could be difficult to see like where the resultant vector is. All right, number 2. Consider two vectors s and t with a magnitude of s and 8, respectively. Vector s is directed at an angle 30 degrees above the x-axis. So when I draw this one, I'm actually going to draw a coordinate plane. This is my x-axis, and it says that vector s is 30 degrees above the x-axis. So if I draw vector s, it is 30 degrees above. And then vector t is 60 degrees above the x-axis. So if I put vector t right here, I can think of it as all of that is 60 degrees. And so if we do a little math here, if from the x-axis to s is 30, and then from the x-axis to t is 60, that means that this is 30 degrees. And so that means once again, I'm going to draw a parallelogram. It's a little funky, but it's okay. So that's 60, and then we're going to do 360 minus 120, which gives us 240 divided by 2 gives us 120. And then our resultant vector is right there. So I kind of made it a little narrow, but that's okay. Oh, I found a mistake I made. I'm sorry. So everybody, give me 1 second. All right, everybody. 360 minus 30 and 30 is 300. 300 divided by 2 is 150. So this should be 150, and that should be 150. So I'm just going to draw the triangle again down here so we can get like a better visual. So this is 150. S is 5, and T is 8. So you're going to do the same thing that you did for number 2. Using the law of sines. So I'm just going to fast forward to c squared. Actually, it's c equals 5 squared plus 8 squared minus 2 times 5 times 8. Cosine of 150. So c equals 12.58. And then once again, this is when it gets a little weird. The direction I told you earlier was from the bottom of the first vector to the resultant, but in reality, it's actually, the direction is from the x-axis to the resultant. So I'm just going to draw this like a little bit more like this. So I just want you to think about it like this. So the resultant, the direction, sorry, is really all of this. So you know that this is 30, but you don't know what this is. You know this is 150. You know that this is 7. Sorry, you know that it's 12.58. And you know that this is 8. So you're going to do sine of 150 over 12.58 equals sine of theta over 8. Sine of theta equals 8 sine of 150. Sine of theta equals 8 sine 150 over 12.58. Do the inverse. And theta equals 18.54. And then you're going to add 30 and get 48.54 for your direction. So direction is like your angle relative to the x-axis. Okay? So if you think about that in comparison to number one was completely flat. So you can kind of like assume like this is the x-axis because it did not say that it was like lifted at all by any degrees. So that's the difference between these two. Okay? All right, let's do some dot products. I'm just gonna erase all this. All right, so dot product, remember, I'm just gonna write like A, B times C, D, like for the formula, it's AC plus BD, okay? So if AC plus BD equals 0, then it is orthogonal. So let's check letter A. So 5 times -4 plus 6 times 8, -20 plus 48 does not equal 0, thus not orthogonal. C, 8 times 9 plus -12 times 6 equals 0, thus orthogonal. All right, and that's pretty much it for the homework.